This tutorial is going to be on inverse functions. Now, I plan to show you how to find out the inverse function, and also I plan to show you how to draw the inverse functions. First of all, let's just start off with a function f of x equals 3x minus 1. Now, to work out the inverse of that function, the best thing to do is to first of all, instead of using f of x, let's just use y equals 3x minus 1. It's just that easier to write and use y instead of the f of x. So we want to make x the subject to find the inverse function. We bring the minus 1 onto the other side, which makes it a plus 1. Once you've done that, you then want to get x on its own, so we divide now by 3. And now that there is your inverse function, but let's just write it out a little bit neater. First of all, like this. And then to finish off, we want it as a function of f. So the inverse function, use a little minus 1 to show it's an inverse function. So again, that's power, elevated to the power there, minus 1. Equals, and instead of using a y here, we're going to be using, it's a function of x, so it's going to be x plus 1 over 3. So there's your inverse function. Okay, so you get that by working out the, by changing the subject to get x on its own. Now to draw this function, first of all, a set of axes. Now there's a few different ways of drawing this, and let me see if I can show you them all on this axis. So first of all, let's just pop along here some points. That's 1, 2, 3, 4, 5, and so on. This way, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and going up this way. Again, you can make it any size you want. Just so you can see most of it, I think, within 5. Here we go, 5, 1, 2, 3, 4. Okay, so first of all, to plot this function here, you can start off at minus 1, because minus 1 is the where it cuts the y-axis. Minus 1 is there. And then the gradient is 3, which means it goes along 1 and up 3. Along 1 and up 3. Going in. Okay, let's just continue this now. So where was I? So yes, so it starts at minus 1. You go, the gradient is 3, so you go along 1 up 3. And the next point would be again along 1 up another 3. So there's 3 points, and with those 3 points you can draw yourself your first function, your first line, which is f of x. Now, you could do the same with this one down here. It'd be a little bit trickier because you'd have to rewrite it as x over 3 plus 1/3. So it's going to start at 1/3, and then the gradient is 1/3. But it's better to actually use this, and what you do is, instead of trying to use the gradient, you just pick some values for x so that this top part can be easily divided by 3. So for example, if I say let x be 2. If it was 2 there, 2 plus 1 is 3, and 2 plus 1 is 3, and 3 divided by 3 is dead easy, is 1. So that coordinate is going to be 2, 1. And we can now put that onto the graph. You go along 2 and up 1, and you can put a little mark there, which is a different colour. And also another point, let's say we could use, let's say if we use 1 plus 1 is 2, well that's rubbish, because 2 can't be divided by 3. I mean, we could put it on here, but it'd be very difficult to plot exactly. It would be better, maybe something like minus 4. Minus 4 would work well, because minus 4 plus 1 again happens to be minus 3. Divide that by 3 is minus 1. So your next coordinate is minus 4, no, not minus 4, plus 4. It is minus 4. So minus 4 minus 1 would be your next coordinate for drawing your inverse function. So minus 4 minus 1 is there. So you could draw a little line through those ones. Again, you can do more points. It's always good to do 3 points, because then you'll see it's definitely in a straight line. Another thing you could try and do if you want to do it a bit quicker is at this point here, if you remember from the original function, is 2, 5. Now because all inverse functions are reflected in the line y equals x, and the line y equals x is a line that goes through the origin, and it goes through 1, 1, it goes through 2, 2, 3, 3, all those functions, so it will go straight up like that there. That's the line y equals x. So all inverse functions are reflected in the line y equals x. So that means what you can do is, if you want to work out where this reflection is going to be, you just flip these coordinates around. So that means if that's 2, 5, the reflected coordinates would be 5, 2. And this coordinate here was, what was it here again? That was 0, 1. So that means the reflecting coordinate, which is going to be over here, is going to be 1, 0. So that's another way, and you'll notice that those points are actually on that blue line as well, which is exactly what it should be. So that's how you find the inverse function, and also how you draw the inverse function on a graph.